Bismillahirrahmanirrahim. Assalamu alaikum, student. I am a physics teacher from IYS school system. Now just follow the instruction. Don't raise hand during lecture. Ask question at the end of the lecture in chat box only. Use hand free if you are using mobile and headphone for computer use. Feed your ID and password properly with your name and class. Take care of time for attending the class. Home task should be done in your fair copy of the subject. If there is any disconnectivity during the lecture, try to join lecture again within 5 to 10 minutes. Students, today we are just going to start the numerical textbook page 31. Because we all of the theory we have read or discussed on the previous classes. So we are solving numericals. Before going to solve the numerical, we just have to discuss which we have done in the previous classes about the SI prefixes. Now for just recalling or remembering your knowledge. So we have discussed about the factor. The first, if the power of 10 is 18, then it is said to be the hexa and its symbol is E. Now, the opposite of the hexa is atto and it is represented by A and its power is 10 raised to the power minus 18. As well as peta, peta is represented by the capital P and its power is 10 raised to the power 15. And the reciprocal of the peta is said to be the femto and femto is represented by the small f and its power is 10 raised to the power minus 15. Now the next one is the tera. Tera is represented by 10 raised to the power 12 and its opposite is pico. Pico is represented by the small p and its value is 10 raised to the power minus 12. Now the next one is giga. Giga is represented by the capital G and its value is 10 raised to the power 9. And the opposite of giga is said to be the nano and nano is represented by the small n. And the value of the nano is 10 raised to the power minus 9. Now the next one is the mega. Mega is represented by the capital M and its value is 10 raised to the power 6, while its reciprocal is micro. Micro is represented by the mu and its value is 10 raised to the power minus 6. Now the next one is kilo. Kilo is represented by the K and its value is 10 raised to the power 3, while its reciprocal is said to be the milli and milli is represented by the small m and its value is 10 raised to the power minus 3. Next one is hecto and hecto is represented by the small h while its value is 10 raised to the power 2. Now, the reciprocal of the hecto is said to be the centi and centi is represented by the small c and its value is 10 raised to the power minus 2. And the last one is deca. Deca is represented by the dA and its value is 10 raised to the power 1. And the reciprocal of the deca is said to be the deci and deci is represented by the small d and its value is minus 1. I hope so you can understand your memory is recall. Now, and next one we are going to solve the numerical. Now, when you read the numerical, you know very well the two things is the most important in the numerical. The first one we can say that is a given, and the second one is said to be the required. Mean given we can say those value which is present in the worst problem or the numerical, then it is said to be the given. And those which have to be determined, those we have to be calculated, then it is said to be the required. Now here the numerical is 2.2 and the mass of an electron is 9.11 multiplied by 10 raised to the power minus 31 kg. Again I am repeating, the mass of an electron is 9.11 multiplied by 10 raised to the power minus 31 kg. And so we can say the mass of electron is given and required we can say convert it in gram, milligram, microgram. Gram is represented by gm, milligram is represented by the mg, and the microgram is represented by the mu g. Now, to solve the numerical, we just have to make up the data. After that, we will write the given which we have seen in the numerical. So in the given we can say the mass of an electron is equal to 9.11 multiplied by 10 raised to the power minus 31 kg. So you have seen in the numerical mass of an electron is 9.11 multiplied by 10 raised to the power minus 31 kg. So we just have to be right in the given. Now the next is required. The first we have to convert kg into gram. Second one we have to convert into milligram. And the last we have to find or convert kilogram into microgram. If you have observed the required, then we can say that in the required all of the things or all of the units are lesser as compared to the kilogram. So if the conversion is going to be smaller, then we have to be multiplied. And if we are going to convert from smaller to the greater, then we have to be divided. Now, first of all, we are going to convert in the solution, we are going to convert into gram. First, we just have to be right. 1 kilogram is equal to how much gram? Then you can see on the picture that 1 kilogram is equal to 10 raised to the power 3 gram. You have learned in the prefix, so 1 kg is equal to 10 raised to the power 3 gram. Now, the given is that mass is equal to 9.11 multiplied by 10 raised to the power minus 31 kg. Here we have to convert this value. We have to convert this value into gram. So when we are going to convert larger to the smaller, then we just have to be multiply 10 raised to the power 3 with this value. So in the next step we can say 9.11 multiplied by 10 raised to the power minus 31, which is present or which is given, and to convert 1 kg, that is equal to 10 raised to the power 3. So at the place of kg, we are computing their value, and its value is 10 raised to the power 3 gram. Are you getting my point, student? Now, the next one is that in the mathematics, we have learned that if the two bases are multiplying and if they are similar, then their part will be added. So let's see this. Here the base is 10, here is the base is 10. So they are multiplying. And in the algebra, when we are multiplying, then their part will be added. So that's why on the next step, we are adding 3 with minus 31. So we will just go to calculate it, or plus minus minus mean 31 minus 3 mean the operation will be the minus. So we are getting 28. And why we are writing minus sign because greater number having minus sign. That's why we can convert kilogram into the gram. Is that the result is m is equal to 9.11 multiplied by 10 raised to the power minus 28 grams. Now just take a screenshot of this page. Okay, now we are going to convert 1 kg into the another unit. Here we have to convert kg into milligram. Kg is greater and milligram is much smaller. So we can say that 1 kilogram is equal to 10 raised to the power 6 milligram. Again, I am repeating, 1 kilogram is equal to 10 raised to the power 6 milligram. Now, after that, we will write the same given, that is m is equal to 9.11 multiplied by 10 raised to the power minus 31 kg. So, according to my previous word, when we are converting larger into the smaller, then we have to be multiplied. So, on the next step, we will multiply 10 raised to the power 6 with this given. Then, so here is 9.11 multiplied by 10 raised to the power minus 31 multiplied by 10 raised to the power 6 milligram. Now on the next step, we will calculate according to the algebraic multiplication. So in the algebra, we have studied that when the bases are similar in multiplication, then the part will be added. So here m is equal to 9.11 multiplied by 10 raised to the power minus 31 plus 6. Now we will calculate it or simplify it. So in the simplification, we can say plus minus minus, then 36 minus 6. In 31, we will subtract 6. So we will get 25. Means m is equal to 9.11 multiplied by 10 raised to the power minus 25. Why we are writing the minus sign? Because greater number having the minus sign. So that's why it will write in negative 25. So this is our required result. Means we have convert kilogram into milligram. Are you understand, student? I hope so. You are just going to try to understand it. Now the next, we will convert kilogram into microgram. Now we will convert microgram into the kilogram. So first we will write 1 kilogram is equal to 10 raised to the power 9 microgram. 1 kilogram is equal to 10 raised to the power 9 microgram. So after that, we will write the given. Given is mass is equal to 9.11 multiplied by 10 raised to the power minus 31 kg. After that, we will multiply 10 raised to the power 9 with this given. So it will become m is equal to 9.11 multiplied by 10 raised to the power minus 31 multiplied by 10 raised to the power 9 microgram. After that, we will simplify it. So we will write m is equal to 9.11 multiplied by 10 raised to the power minus 31 plus 9. Then we will simplify it. So here plus minus minus plus minus minus. So we will subtract 9 with 31. Then we got 22 and we will put minus sign because greater number having the negative sign. So that's why it will become m is equal to 11 multiplied by 10 raised to the power minus 22 microgram. So this is the required result. Okay, student, just take the screenshot within 15 seconds. Okay, now the next numerical is 2.3, and in this one it is saying that the radius of hydrogen atom the radius of hydrogen atom is 0.53 multiplied by 10 raised to the power minus 10. Mean here the given is the radius of hydrogen atom is 0.53 multiplied by 10 raised to the power minus 10 meter. So here we have to convert it in centimeter, cm, millimeter, mm, nanometer, nm. We just have read in the SI prefixes. Now here we just have to be sure that what does radius mean? Radius, we can say the half of the diameter is a radius. Now after that we are going to make up the data. Now we are going to make up the data, and in the data first we will write the given, then we have to write the required. So here, first of all, given you know very well, I was told you that the radius of hydrogen atom is 0.53 multiplied by 10 raised to the power minus 10 meter. This is the given, and the other one, the conversion, is said to be the required. So, in given we will write radius of hydrogen atom. Radius of hydrogen atom is equal to R, and R is equal to 0.53 multiplied by 10 raised to the power minus 10 meter. Now, after that we will write required. The first required convert into centimeter. The second one is convert into millimeter. The third one is convert into nanometers. Okay, so in this, take the screenshot. Now, the next is the solution. First, we will convert meter into the centimeter. If you observe that meter is greater than the centimeter, here we will multiply it. So first we will write 1 meter is equal to 10 raised to the power 2 centimeter. 1 meter is equal to 10 raised to the power 2 centimeter. Then given is radius of hydrogen atom is equal to R, and R is equal to 0.53 multiplied by 10 raised to the power minus 10 meter. Now, next one is R is equal to 0.53 multiplied by 10 raised to the power minus 10, and we will multiply this. Multiply by 10 raised to the power 2. Then, because we are computing the value of meter, is 1 meter is equal to 10 raised to the power 2 centimeter. After that, we are multiplying it. Here the bases are similar, then the power will be added. So we have to write R is equal to 0.53 multiplied by 10 raised to the power minus 10 plus 2 centimeter. So after that we will calculate it. After that we will calculate it. So plus minus minus 10 minus 2 is equal to 8, and we will write the sign of the greater number. So the required result is that R is equal to 0.53 multiplied by 10 raised to the power minus 8 centimeter. Okay, take the screenshot. Now the next conversion is that convert into millimeter. Millimeter much more smaller as compared to the centimeter. That's why we will write 1 meter is equal to 10 raised to the power 3 millimeter. 1 meter is equal to 10 raised to the power 3 millimeter. After that, we will write the given. R is equal to 0.53 multiplied by 10 raised to the power minus 10 meter. After that, we will multiply it. So, R is equal to 0.53 multiplied by 10 raised to the power minus 10 multiplied by 10 raised to the power 3. So, we are just going to calculate it. So, we can write R is equal to 0.53 multiplied by 10 raised to the power minus 10 plus 3 millimeter. So plus minus minus. So we can say R is equal to 0.53 multiplied by 10 raised to the power minus 7 millimeter. So this is the required result. Now next one is convert into nanometer. So nanometer is much more lesser as compared to the millimeter and centimeter. So 1 millimeter is equal to 10 raised to the power 9 nanometer. 1 meter is equal to 10 raised to the power 9 nanometer. So R is equal to 0.53 multiplied by 10 raised to the power minus 10 meter. Now, after that, R is equal to, we will multiply 10 to the power 9 with 10 raised to the power minus 10. Then, we will get plus minus minus mean 10 minus 9. So 10 minus 9 will be equal to 10 raised to the power minus 9 nanometer. So R is equal to 0.53 multiplied by 10 raised to the power minus 1 nanometer is the required result. Now just take the screenshot. I hope so, student, you will get the point. I will just share your question at the last minute. Okay. Now we are going to see the last one. Last numerical is the time taken by an electron to complete one rotation about its nucleus is 0.5 multiplied by 10 raised to the power minus 18 second. Now minutes, convert into minutes, hours, microsecond. Here one thing is much more confusing. Uh, we just have to be convert second into the minutes, hours and microsecond. Now here two things is greater. Mean minute is greater than the second, while hours is greater than the second, while microsecond is smaller of the second. So here we just, if we are going to convert minute and hour, so we have to be divide. So we have to be divide. And in the microsecond, we will multiply it. Now, first the given is that time is equal to 0.5 multiplied by 10 raised to the power minus 18 second. Required is convert into minutes, convert into hours, and convert into microseconds. First of all, we are going to convert into minutes. First, 1 minute is equal to 60 seconds, but we have to convert second into the minute. So we will divide 1 with 60. So we can say 1 second is equal to 1 upon 60 minutes. 1 second is equal to 1 upon 60 minutes. After that, given is t is equal to 0.5 multiplied by 10 raised to the power minus 18 second. Now, 1 upon 60 will multiply by this. So, we have to going to calculate the solution. 0.5 will multiply by 1. So, 0.5 ones are 0.5 and divided by 60. We will just write as it is 10 raised to the power minus 18. So their unit will convert into the minute. Now, 0.5 will divide with 60, then we will get 0.0083333, while 10 raised to the power minus 18 will remain same. This one can be the answer, but in the mathematics, we are going to calculate in a smaller way. So we just have to be convert it in the scientific notation. So this decimal will be shipped after 1, 2, 3 digits. So we just have to be write 8.3333, and when we are shifting point from left to right, then the part will be in negative. How many digits we are computing the decimal, so that will become the part. Here we have shifted decimal after 3 digits, so that will become the part 10 is to the power 3, and minus sign mean it is shifting, decimal is shifting from left to right, so it will become the negative. Now the next one, 10 raised to the power minus 18 will remain same. So in the multiplication we will add their part, so it will become 8.33 will remain same. 10 raised to the power minus 18 minus 3 minute, then it will add it, so it will become t is equal to 8.33 multiplied by 10 raised to the power minus 21 minute. I hope so, students, you will try to understand it. Any confusion about that, I will just share your problem in the last one. Take the screenshot. I'm just going to shift on the other way. Now, we have to convert into the R. Here, 1 R is equal to 3600 second, and 1 second will be equal to 1 upon 3600 R. So we have to multiply this with given. So we will get t is equal to 0.5 multiplied by 10 raised to the power minus 18 multiplied by 1 upon 3600 hours. Now the next one, 0.5 will multiply by 1. So we get 0.5 divided by 3600 multiplied by 10 to the power minus 18 R. After that, we are getting 0.000138 when we are dividing 0.5 with 3600, and the part will write as it is. Now we will shift after 4 digit. We will shift decimal after 4 digit, so it will become 1.38, and the part of the 10 will become 10 raised to the power minus 4. 10 raised to the power minus 4. So and multiply by 10 raised to the power minus 18 will remain same. Now, in the next one, in the multiplication part will be added. Part will be added. Then it will become t is equal to 1.38 multiplied by 10 raised to the power minus 18 minus 4 r. And the last one we will add, and the sign will remain minus because both sign having the negative. 18 plus 4 we get the 22. So 1.38 multiplied by 10 raised to the power minus 22 r. Now the next one is convert into microsecond. 1 second is equal to 10 raised to the power 6 microsecond. Then given is t is equal to 0.5 multiplied by 10 raised to the power minus 18 second. So we have to multiply it. 0.5 multiplied by 10 raised to the power minus 18 multiplied by 10 raised to the power 6 microsecond. So they are multiplying. Then t is equal to 0.5 multiplied by 10 raised to the power minus 18 plus 6 plus minus minus. So 18 minus 6 we get 12, but the sign will be the negative. So t is equal to 0.5 multiplied by 10 raised to the power minus 12 second. Now we just have to be end. Now student, your home task will be the mass of an electron is 9.11. The mass of an electron is 9.11 multiplied by 10 raised to the power minus 31 kg. So convert it in nanogram. Now the next one is the radius of hydrogen atom is 0.53 multiplied by 10 to the power minus 10 meter. Convert it in kilometer. So just take the screenshot. Okay, student, thank you so much to participate with us.